All right, as promised, I'm going to do another screencast, going over the same thing we did in class today that I forgot to screencast so that you guys will have it. Here's the system that I had drawn on the board, where we have a triangle and we have a local coordinate system S and T. We have a global coordinate system X and Y. Okay, the relationship between those two coordinates, between X is A1 plus B1S plus C1T, and with Y it's A2 plus B2S plus C2T. And we want to find out what these constants are, A1, B1, C1, A2, B2, C2. And we can do this by evaluating, we can come up with 6 equations by evaluating X and Y at the 3 nodes. Okay, so 3 nodes, X and Y, will give us 6 equations. Okay, so we'll start, I'm going to call the first equation equation 1, and it's going to be X evaluated at S equal to 0 and T equal to 0. Okay, so that's the location of this node right here, and X is equal to X1 at that location, okay, in the global coordinate system. So set that equal to X1. That'll give us one equation. Equation 2 is Y evaluated at the same point, which of course is Y1. Okay, and the third equation, we're going to evaluate X at now this point in the local coordinate system ST. S is equal to A and T is equal to 0. So we're going to have A 0, that's equal to X1. Equation 4, Y A 0 equal to Y1. Fifth equation now, we're going to evaluate it at this point. Okay, so this is located at S is equal to C now, this distance, and T is equal to B, so it's this distance, and that point is X3. So we're going to have C, B, X3, and equation 6 is going to be Y, evaluated at that same point, is equal to Y3. Okay, so now we have 6 equations. We can solve them for the unknown constants. So we'll call that the answer we get, solve. So we're going to say solve equation 1, equation 2, equation 3, equation 4, equation 5, equation 6, 4, A1, B1, C1, A2, B2, C2. And so there's the solutions. Okay, so if we now we want to determine what the shape functions are in the global coordinates. Okay, and so we'll do that. I just pasted in what the shape functions we had derived earlier in the notebook for a triangle. But now in the global coordinates, we have x1, y1, x2, y2, x3, y3. So these are the shape functions. There's 3 of them. This is one, this is another one, and this is another one. Okay, and they're functions of x and y. Remember that x1, x2, x3, y1, y2, and y3 just correspond to these points up here. Okay, and the independent variables here are x and y. Okay, so if we evaluate these shape functions, okay, defined in the global coordinate system, now we want to convert them to the local one in terms of S and T, what we can do is we can evaluate these shape functions with x equal to x st and y equal to y st, and then evaluate that. This is these x and s and t is just going to reproduce this equation. We want to plug in the values a1, b1, c1, and the same goes for y. It's just going to reproduce this equation. We want to plug in the values a2, b2, c2, which we solve for here. So we'll evaluate this whole thing with sol, and get that, which we can then simplify, and we get something a little bit nicer. Okay, I just noticed this is wrong, so I look back and I notice I made a mistake. Right here, this should be x2, and this should be y2. Okay, x3, y3. Okay, so now these equations are right. I should have picked that up here, because these are far too nice. Let's see that they're a little uglier now. These won't change. Now when we get this, okay? Now, just for observation purposes, if we evaluate, that's the three shape functions, okay, defined in terms of the local coordinate system. If we now condense it down to one side, so we're going to look at the side that goes from 1 to 2, okay? Along that edge, S is equal to S and T is 0, okay? So if we evaluate that, we say that S is equal to S, we won't write that in, but T is equal to 0. Okay, now we have this, and this should look quite familiar to us. If we just take this one line segment, of course, previously, to make it look like what we've seen before, you'll notice that if I let S equal X and A equal L, we get the shape functions of a line segment that goes from 0 to L. Okay? So this is the screencast, basically just reproducing the result from class today. Thanks.